So, good morning, everyone. Welcome to our CIRCOMOD webinar. So we have a very packed agenda, as you can see. So I will jump these introductions, and I think we can move to the first presentation from data to the project, and then we'll jump. So each presenter has 7 minutes, and I will be very strict with the time. So when it's almost 2 minutes to finish, I will give you a sign, okay?
Yeah.
Okay, the floor is yours.
Thank you. Yeah, so my name is I'm PI CIRCOMOD. We're here now in Freiburg. Place to present our work. And in the coming 1.5 hours, we will have the different work leaders presenting work that has been done in CIRCOMOD. And yes, sorry. So CIRCOMOD is about the use of materials. And materials play an important role, of course, in our society. They help to provide all kinds of services and therefore contribute to our welfare. Yeah, but unfortunately, the way that we use them in a linear way also creates a problem of extraction and depletion of resources and creation of waste. And the second problem related to it is that it costs energy to produce these materials, which contributes to climate change. And to focus a little bit on that. And so this is the current situation with respect to emissions. Speak louder. Yes. Okay, so I will try to do that. So if you look at the right, you see the expected emissions according to current policies in red globally, and you see the green. You see in green the direction that we have to follow a 1.5 degrees trajectory. So there's possibly a problem with the sound if people are looking into this. Is this the mic that is currently used, or it should be this one? And that one works fine?
I don't know. Better now.
Okay, better now. Okay, perfect. Then I will continue. And so you can see that on the slide on the right, that at the moment the climate policy is far from being on the trajectory to 1.5 degrees. And in models, typically, we are looking into climate policy in terms of energy efficiency improvements, in terms of decarbonizing energy. But in the models that are looking into climate policy, typically we're not looking into the material efficiency, which automatically creates this option that we can, with circular economy policies, kill two birds with one stone. On the one hand, we can contribute to maybe closing that gap between current policies and 1.5 degrees for climate, and at the same time make the system much more sustainable and rely less on primary resources and create less waste. And so therefore, in CIRCOMOD, we have decided to look into the system and to look into the connections between material flows, between the energy system and greenhouse gas emissions, and into the contribution that materials have for the economy. And that's indicated here with the green material flow boxes, the reddish greenhouse gas and energy boxes, and the blue economy boxes. And the idea of CIRCOMOD is to look into the systems and particularly also think how circular economy measures like reduce, rethink, repair, and recycle can help us to reduce material use. And so the objective is to see how circular economy can impact greenhouse gas emissions. And therefore, we want to, first of all, develop a scheme to look at this, to collect the data, to look into CE options, to expand both the material flow models and climate mitigation models to look into this, but also economic models to look into the economic circular economy consequences. Then to use these new models to develop scenarios, and then also contribute to developing simply connections among different research arenas. The integrated assessment modelers, the people working on material flows, people working on LCA, economic modelers,
and therefore create a new interdisciplinary network of researchers. And the setup of the project is along the lines of these sub-goals. We have some work packages that look into reduction options. We have work packages that work on an analytical framework. We have work packages that look at developing data hubs, and finally a work package looking into the scenario development. Yeah, and in the project we have several modeling teams. I already pointed out earlier that we have a focus on both materials, energy and climate, and economics. And so we have material flow models like REC and image materials. We have integrated assessment models like image, width, and times. Also, by the way, Remind now. And then also several macroeconomic models to look into circular economy options. And we intend in the project to link information between those models and also to harmonize their analysis. Yeah, progress so far, we're now in the third year. We have done a review of models and policies. We have worked on analytical framework. We have reviewed supply and demand reduction options. We set up a data infrastructure, and some of these options will come back in the presentation of the work packages. And we have done some first exercises on scenarios. To give an example here, the project also contributed to the global resource outlook of the IRP. And there we looked into already the potential consequences of circular economy measures for climate policy, as showing that it's indeed possible to contribute to reducing greenhouse gas emissions via circular economy measures. And this report was published last year with a contribution also from CIRCOMOD teams. Yeah, that means that I will now hand over for the next of the presentations. We have a couple of people presenting the different work packages. First, Oriane Edelenbos will say something about the analytical framework. Then Peter Beryl will say something about our demand side. Tobias Fiere will say something about circular economy profiles. Then Leonidas Paroussous will say something about circular economy strategies and CGA models. Stefan will present an important part of the project related to data. And then finally, we will say something about the remaining work plan and how you can engage with us. And so that is back to the next speaker.
Okay. Other way. Yeah. So I'm happy to present the analytical framework. My name is Oriane Edelenbos, but I'm presenting this on behalf of many people involved in CIRCOMOD, some of them listed, but it's actually really a whole team effort. What is the analytical framework? It's really kind of the blueprint of how we in this project want to together look at how CE measures can contribute to greenhouse gas emission mitigation. And so there are different activities that contributed to the development of the analytical framework, but I'm going to focus just on two of them. So one is the literature review that was led by Patricia Fortes and Marianne Zanon-Sotin. And this was actually not one review, but it was 3 reviews looking at CE policies on the one hand, CE strategies and potentials, and different CE modeling approaches. And the idea was by looking at these 3 different topics also to be able to understand the gaps. So are the policies addressing those measures where there is most potential? Are the modeling tools able also to assess the policies and direct it to the most relevant sectors, etc. A second activity was the development of stylized models. So these stylized models were basically, yeah, they look at their simple representations of the problem that we are analyzing, and they really show kind of key dynamics. And so that was really the start also of this project, to develop these stylized models to understand what to focus on further along the way. So some highlights from the review. So this was, I'm going to start with the review on CE strategies and potential. And this was a systematic review where we really looked at studies that quantified also the contribution to reducing greenhouse gas emissions. So that was a criteria for studies to be included. And we started with a sample of 2,000 papers that was then narrowed down to 200 papers. Still a huge effort to code all these. And you can see here the distribution across different materials and across different sectors, where you see also the wide difference between the different materials, with those more energy intensive materials more represented. Vehicles in terms of sectors, infrastructure, consumer goods and machinery are also more covered. And it's good to note here that in the review, we didn't look at buildings, but buildings is also a sector where there is a lot of information. We didn't consider it because there was a recent review done. So we just directly, instead of redoing the work, refer to that. And so if you then compare the different CE measures across the different sectors, you see that there's really a different distribution of measures looked at, where recycling is basically represented across all sectors, and rethink and reduce is also a lot of papers studying that, with a few kind of hotspots. Rethink in measures considered related to infrastructure, reduce more in steel and non-metallic minerals. But you also see a huge gap in the slowing our strategies and in the refuse strategy. We did a similar exercise for policy, and here you see a bit of a different view where, well, one thing that is similar is that also policies are mostly focusing on recycling, even though the higher R strategies are known to be more impactful. But there are also more recently policies that are focusing more on the slowing measures. All right. So based on these reviews, we developed the scope of the project. You can see the different key sectors that we found also in the review. Those are the sectors that we focus on in CIRCOMOD, and we relate them to the services that they provide. That also allows us to assess different higher R strategies. And then for these different product groups, we look at the whole life cycle, right? So from mining to different engineered material groups, manufacturing, and all the way up to waste. All right, so quickly then the outcomes of the review on CE modeling approaches. Here we assess all different types of modeling approaches that are used for this, that look at the relationship between CE and greenhouse gas emissions. And we characterize them over different dimensions: spatial scope, temporal scope, the outputs that they generate, and in what way they assess CE measure potential. And so we looked at LCA studies, material flow analysis, input-output, general equilibrium, IAMs, DES, system dynamics, ABMs, and OR. And for our work in CIRCOMOD, we're mostly interested in macro studies, studies that have a dynamic temporal scope, that look at technological, environmental, economic, and social outputs, and also that analyze technical, economic, and market impacts of the different CE measures. And so what we found is basically the type of models that are also represented in CIRCOMOD are really well suited for the challenge that we want to address. Okay, finally, very quickly, because I know I'm running over time. So different stylized models have been developed in CIRCOMOD, and you can find them also in the website indicated before, circomod.eu. 5 in total. Here I'm going to just highlight 2. The CIRCI model, which is a general equilibrium model. It's really links lifestyle with material stocks. It's been developed for Europe and for Japan, and analyzes repair, reuse, refuse, and rethink strategies. And you can see here on the right how it's for different types of scenarios assesses material flows, energy flows, emissions, etc. The details can be found in this paper here on the top. Another model, a stylized model that was developed is or actually there are two, MOD CGE and Green CGE. And they've been developed to track material flows in CGEs, looking at dynamic material intensity, so not static, but really how material intensity responds to policies. And these models are very informative also for the development that's been occurring in the bigger CGEs that are part of CIRCOMOD. And so you see here on the left, the figure shows how the effectiveness of different policies can be assessed. I'm going to leave it with that. So up to the next speaker. There you are.
Good morning, everyone. Nice to see everyone here in Freiburg and also online. I will give an update from work package 3 on demand side modeling and our current work on interlinking different types of models to look at the potential from different demand side measures. So here's a scenario framework that Detlef shared with us before, and the different type of scenario space that we are looking at modeling in this project. So basically there will be developments in climate policy, and we can capture some differences there. And then there are a large suite of different circular economy policies, which we can categorize by the R strategies, but also some into the more aggregate, narrow, slow, and close. So I'll give a brief update now about where are we currently with our models, where does it look like we're going before implementing circular strategies, and where might we go after implementing circular strategies, and how might we model some of the demand side strategies. So what a deliverable we are working on in the coming months is changes to service levels, material flows, with and without these measures, how stocks might change, and first get an initial feeling for the dematerialization potential and the decarbonized potential from different measures. A little summary of where we are now from our past work, looking at, for example, service levels globally. In the map, we see variation in residential floor area per person. And on the right is a graphic of material stocks per capita on a log scale and organized by different sectoral groups. So we have buildings on top, followed by infrastructure, vehicles, energy infrastructure, and then household appliances and goods. And yeah, you can see that there are basically orders of magnitude difference in how much materials there are in these different sectors. Most of the materials are in buildings and infrastructure. So where might we be going before implementing some circular economy strategies? Here are some examples of different projections in service levels from some of the models that we have in CIRCOMOD. This is from Image, from REC, and from Times for demonstration of Europe or European Union, however it's defined in the models. And basically we see a steady growth from different levels from the current level throughout the next 40 years or so. Similarly in passenger demand, there's quite a range of both current and projected levels of passenger transport in the different families. Some of this is also explained by different mode coverage. So some models are focusing on passenger vehicles, and other models have a wider range of transport mode included. And then how this translates into material output. So from a couple of the models, REC, Times, and Image, here we see, for example, primary production of steel in Europe throughout the next 40 years. So this is kind of a base case without any ambitious circularity measures. And what we have started to do now is think about how we will, what targets we will set for future scenarios, how service levels might change, for example, in the building sectors and transport. This is just a demo for some numbers that we have taken from literature or come up with for these particular end uses, but we will basically repeat and extend this over the different sectors covered. Yeah, and how we're doing this is basically we have mapped from all the different models what our strategies can be related to different variables, exogenous and endogenous variables in each models. And then, yeah, first of all, we want to align some of the important variables a bit better in the starting and also harmonize model regions before, yeah, our next steps, which is, yeah, implementing these scenarios. Some special element of CIRCOMOD in general is the integration of and deeper integration or new connections between different modeling families. So for example, between integrated assessment models and industrial ecology material flow analysis models. So for example, we have connections being developed between the REC model and the TIMES model. And similarly, there is evolution of the image models from the base image model to include more detailed representation of the material cycles from the image materials model. So this is something that's very special in this project and will hopefully enable us to get a better insight, more comprehensive understanding of what the meaning of the different circular measures are. This scenario initial target setting also has a close interaction with the work package 6, which is basically developing the narratives and quantifying the scenarios that we will model here. So that is the update from work package 3, and I'll pass to the next speaker.
Yeah, good morning, everyone. My name is Tobias Vierer. I'm from Pforzheim University, and I'm going to present some inputs from work package 4 on circular economy profiles. To put that in perspective, so we are working together with the Freiburg team, and Pforzheim, for those that don't know, is if you enter from Freiburg here into the Black Forest and walk 4 days non-stop through the Black Forest northwards, you'll end up in Pforzheim. So that's, and those two teams teamed up and we developed circular economy profiles. And the whole purpose of circular economy profiles is to make our results of the CIRCOMOD project more visible, to communicate it to the general public, to policymakers, practitioners, and so forth. So that it's not only an exercise for academics, but that it really gets a good level of attention and gets relevant for all different levels of decision making. We did that by, as always, looking at literature first, but then we involved a lot of stakeholders from different stakeholder groups that are relevant, talked to them, asked for their demand in terms of what do they need to know about circular economy and it links to climate change and so forth. And we came up as a result of that with 3 different types of circular economy profiles. One for materials, like for copper, one for sectors of products, like for building or machinery, and one for whole regions, like countries within the European Union. And each of these profiles has about, like a 2-pager with additional information available on the web. So all the profiles look very much the same. You have the status quo described there, you have future stages described there, and then you assess the stages in different dimensions. So socioeconomically and environmentally. I can quickly go through some examples here. So for instance, in the introduction, you will find some general information on a particular product or sector or material. In this case, the example is given here for for the building sector. So you will see the current state of the building sector. In the next step, you see the current state of circularity of that sector. And then also on the lower part here, what is the circular economy potential, represented by various indicators like total material consumption or intensity of use, etc. And this is then on the second page assessed by socioeconomic assessments, like investments or persons employed and other indicators, but also by an environmental assessment and followed up by some recommendations. All this is, as a concept, fully developed, but of course, throughout the project, more and more data will be entered so that these profiles will really be useful and can be published. On top of that, we have an online tool that's hosted here in Freiburg, and that enables you, if you are more of an expert and you want to play around with the data and develop your own scenarios, then you have this online tool to more or less build your own profiles in addition to what I have just shown. So basically, how we will put further data into the profiles, we will publish them step by step, and that's part, as I said, of the work package 4, which will be continued within the next months. And with having said that, you have seen a very short intro to our circular economy profiles, and I can already hand over to the next presenter.
Okay, being very fast. The next one. Leon.
Okay, thank you. So I'm going to discuss a bit the developments that we are doing on the CG modeling and how to better represent the circular economy options. I want to highlight some of the challenges, the current status, and the next steps. I want to remind why we want to include or to introduce the circular economy into the CG modeling. So it is very important to understand how the materials and the circular economy consumption and production affect energy consumption, emissions, and trade and the economy. So in this case, we want to improve the way that the models react in energy taxation, carbon taxation, or changes in behaviors, changes in consumption patterns, to identify the technology dependence in terms of materials and the value chains and how this is important across regions and sectors. What could be the trade growth effects from bottlenecks in materials or from increasing prices in specific materials, and identify any the positive effects that let's say material efficiency can bring in some sectors, in some economies, which is unexploited. So you can actually reduce energy consumption or reduce emissions with positive gains. And of course, lastly, to understand better the economic, let's say, importance of sectors like waste and recycling, which up until now in most CG models is, let's say, not well developed. So there are, let's say, 4 main models. It is the IC that is used. I mean, 2 have been mentioned before, but I will mention them again. So it's the ICES. It is a large-scale applied general equilibrium model intertemporal. Many countries, many sectors, fully linked, quite detailed. The GEMI3 model, microeconomic model, linking all countries with bilateral trade flows. A characteristic that it has is that it represents the clean energy technologies separately, I mean the manufacturers of these clean energy technologies. And then it is the green CGE by PBL and the MAT CGE from the Tilburg University, which is used in order to, let's say, better understand the relation between developing, let's say, the physical volumes and the monetary volumes and how these two can be consistent. So we have global coverage. The models are calibrated in the latest GTAP version, GTAP 11, in the circular economy version, which allows a quite flexible granularity in terms of sectors and regions. The standard, let's say, version of the big models is around 50 countries, regions, and around 60 economic activities. Depending on, let's say, the exercise, this can be aggregated or disaggregated. Now, the main model developments that are taking place relate to the identification of additional activities, additional industries, additional products, but also changes in consumption and production structure. So the primary and secondary markets are now identified separately. Recycling is identified separately. Material efficiency is, let's say, identified separately. And stocks and flows are now, let's say, accounted in a more detailed way. The key, let's say, aim here is to have a consistency between the energy intensities of the materials, the greenhouse gas intensities of the materials, the material intensities of the technologies that use the specific materials, and this to follow, let's say, a consistent a consistent accounting scheme, both in the monetary, let's say, level and in the physical volume level. The key materials that are now represented, I mean, through these extensions in the models are iron, copper, aluminum, and rubber. These are mostly because these are available on a global scale from the GTAP dataset in the circular version. It is easier to, let's say, to have this complete picture. Once this, let's say, representation is finished and the models are fully equipped with these new features, extending to other materials, rare earth materials, or I mean, it is straightforward if data are available. Now, once this extension is fully operational, the models will be able now to calculate or to report and to make simulations that go beyond the impact, let's say, on GDP and sectoral production, but will better understand the size of the primary and secondary markets. We'll be able to better understand what is the autonomy that the different countries have in developing their own supply of some materials through recycling, through developing better the secondary market. What is the bilateral trade flows and the dependencies of materials? And then to better understand what are the substitution possibilities between different materials according to the technologies that each sector can deploy. Now, the main challenges are in representing the circularity in the CG models. Has to do, of course, with data. I mean, in terms of having a balancing between the monetary transaction and the physical volumes. I mean, the input-out tables are reconciled based on the national accounts. Energy balances have different principles. Material accounting has different principles. So all this together, reconciliating and having a balanced ecosystem, let's say, approach is quite difficult to establish. But at the same time, the circularity or the transition to more circular measures entails a change in behavior. And a behavior that is not necessarily price driven. It can be driven by many other characteristics. So in terms of modeling, this, let's say the default or standard or what we are using now is an exogenous assumption. So for example, households can, let's say, adapt more car sharing methods in terms of mobility or but it's not an endogenous, let's say, decision of the economic agent. But this is very important because this could lead to growth effects that are there, but are driven, let's say, by this exogenous part or it's assumptions driven. So, of course, we have policy-driven, let's say, circularity adoption, which is modeled and it's straightforward to capture, and cost-driven, so subsidies, taxes, taxation, changes in technology costs. Yes. Now, the circularity potential for each sector and how, let's say, how costly or not it is to engage this is also a very significant aspect of the modeling. So here it's just an example, so don't take the numbers exactly. I mean, this is a very indicative scenario where we have introduced circular measures to iron and steel, to non-ferrous metals, but to specific sectors for iron and steel, for let's say, and productivity improvements for let's say cars, for equipment goods, for construction, cement in construction, plastic in construction, consumer goods, and let's say equipment goods. And we can see what is the impact of a 25% of efficiency of material productivity in GDP for the EU in these different sectors. And the cement is, let's say, the increase of productivity. So this is cement circular option, figures out to be the best in terms of both improving, let's say, GDP and reducing emissions. Here it is very important to understand how each sector is linked with the other sectors, the multiplier effects. So it's not only an energy consumption reduction or an emission reduction, but it's also the sector itself, how it contributes to the whole economy. So I will not take much more of your time. We are currently improving the material accounting and developing the models, and we are going to develop a set of pilot simulations in order to test the model properties in the near future. So thank you very much.
And we have the first questions in our sheet.
Quickly check the setup somehow, but it's working, right? The microphone as well. Put it on the right mic. Thank you, Leonidas. I will continue with presenting you the data hub. Stefan Paulik from the University of Freiburg. We have our model framework. And we have a vast array of input data. We have the economic input data, stocks and flows. Peter showed some of them already, technology descriptions. And we will produce a vast array of output results. There's the footprints that we're interested, of course. There's labor effects, but also future service levels. So we need to structure this data, and many of them we do want to make available later on. On the input side, we have table-based data, time, product, material, region, and we can adopt existing data infrastructure and data models to format all this data. So this has already been rolled out to work packages 3 and 4. And we can also include economic input data because they can also be organized in tables. And by using project-wise classifications on regions, on materials, on sectors, it is easy to make this data interoperable. And the format or the infrastructure we use here is the Industrial Ecology Data Commons. So this is an actual implementation that we have built for this data model. So we have all this data organized. We have collected data from all kinds of sources and brought them together in a common format, in a common data hub. And the idea is here for this project to further enrich the database of the community. But again, it's called industrial ecology, but the data model is more general. So we can also add economic layers to this. And we have just an example for the workflow that we will establish. So let's say we have a model coupling. We need to start from current in-use stock levels, have the future demand for services, have prices and costs. So this are data from the colleagues and the work packages that we have just presented. And we would then go into industry parameters. And how does it now work? Well, first of all, we have a repository for our classifications on GitHub where we have the actual labels that we use for the different items. We then have, and this is something new, implemented by Nildem since the last project meeting, we have a template validator. So if you structure your data in the templates that we've been using in work package 3 and 4, it's now possibly, and this is an open tool now, to go with your data template and have it validated against the database. And since formatting is okay, labels are okay. So it really checks the data for consistency. And you get, nice thing is you get a PDF report from it. And one of our deliverables is we will churn in 100 different data sets through this validator, and we will have 100 PDF reports showing the data are valid. So this is what we're going to do. So the ambition is that we have an additional 100 to 150 consistent data sets that are of interest for the global community in material composition, lifetime, costs, price, process inventories. So, and some of the data, depending on licenses or depending on whether people want to use this in their own projects first, will be published for earlier or later, both mirroring them on Zenodo and also having them in the database. On the output side, we mostly have time series data. And here we chose to convert all this data into IMC scenario templates to be able to be consistent with the IIASA hosted database, the Scenario Explorer, for later use and comparison. And here Marianne is leading the work from the framework side on getting all the different indicators together. We'll show them in a moment. So we have to expand the established scenario indicators to greenhouse gases, to materials and resources, and also to circularity measures. So we are working also here on these time series templates in the IIASA framework. And this works by having a common, at the moment, unofficial project by CIRCOMOD and the Circular project, where we can expand together the list of materials to be able to report more details. You can maybe read some of here. There's the production volumes in physical units and also monetary units. There is the materials demand from society, and there's also the collected scrap. So this can then lead directly into model comparison projects. And the IM community just published in Nature Energy this weekend, I think, demand side solution assessment on vehicles and buildings. And this will be here then the basis for more of such assessments. And this all will be populated by the end of the project. And with this, I can hand it over, I think, to Detlef again.
Yes, thank you. So I think this was quite an impressive overview of the work that has been done so far in the project. And so the last few words are simply on what we are going to do in the next 60 months that are now left in the project. And so first of all, more or less we had 3 phases in the project. One phase is developing our analytical framework. The second phase was really collecting data on all kinds of options to introduce circular economy options and to start improving the models. And we're now going into the last phase where we start developing scenarios and do our analysis. And we first of all need to finalize the second phase. So we will have to finalize the reporting on the intervention options and finalize the model improvements. And then we will start developing the CIRCOMOD scenarios, which means that we will look into impacts on emissions and economy, resource use, trade and environment. And what we intend to do is to obviously share all those results. First of all, via all kinds of scientific publications, but we also are targeting several conferences where we would like to engage also with the community. One of them is, for instance, the Integrated Assessment Modeling Consortium. And there, together with some other projects, we already have also made a proposal for a breakout session specifically on circular economy measures. We're going to present our results at the EGU, where there is a session organized by people involved in CIRCOMOD on circular economy modeling and the links between integrated assessment modeling and material flow models. We present our results at the International Conference on Industrial Ecology. You have seen the presentation on the Data Hub. I think this is a really important tool for us to share information with the rest of the world, and so there will be a lot of work in the coming years to fill that. And you have also seen the CE profiles, which are a nice way to communicate our results to a broader set of stakeholders. And we have planned this final CIRCOMOD conference in 2026, which potentially we could also organize together with other projects. We still have to fill that in. Yeah, so I already indicated that we will be working on scenarios in the last period. We are planning to look into the impacts of circular economy strategies on climate policy. So this is a logical framework to use. We first of all look into how to reach climate goals along with Paris without circular economy strategies. And then we do a second set of scenarios where we introduce a set of circular economy measures and see how that actually changes the ability to reach Paris goals and the cost associated with that. And so this is this framework that has been set up in that way. During the project, as part of, for instance, of the review, we saw these different R strategies, and we realized that it's practical to group them, and we grouped them parallel projects on circular, also grouped them in a similar way. And so you can see these different R strategies that is partly related to smarter product use and manufacturing, let's say narrowing the material flows. We have a group of R strategies that are much more about lifespan expansion, which you could classify as slowing. And then finally, we have we have two R strategies that are related to recycling, which you could say as closing the material flows. If we have these three major strategies, we could potentially bring that also into our scenario framework and introduce the different R strategies in 3 steps, where we first look into a situation without circular economy measures, then introduce the measures related to narrowing, slowing, and closing in subsequent steps, and then finally see how the impact would be of full CE strategies on reaching the Paris goals. Yeah, so we would like to continue to engage with the community. For us, this was a nice way to start our project meeting for the first time, really with the community at large. And we'd like to continue to do that. And so we're happy to organize sessions at conferences with also the people now online, which are not officially part of CIRCOMOD. Please contact us also via our website and follow us on the social media channels. We have in the past already other teams that have formally or informally joined CIRCOMOD, and we're happy to consider if you're interested. The interactive data hub will be a way for us to share the data that we have, and we are very interested also to see if there's additional data from others that we could absorb into the project. We will make the scenario protocol that I just introduced open access, which means that other people could do the same analysis and compare results. And obviously also the scenario database will be published. When Stefan presented the scenario hub, he distinguished between input and output. I think in reality, somebody's output is probably the next person's input. And so we can also make that data available for others to use. And that's where we would like to end. And so I think I'll hand over to Patricia.
So thank you all the speakers. I think now we can open our Q&A session. You can raise your hand and you let you speak in your micro, or you can write on the Q&A short. So we already have a question from Thomas. Thomas, I'm not sure if you are there yet still, but I'm not sure if you want me to read the question or if you want to speak. You just raise your hand, but I will read it. I'm not sure for who is the question. So Thomas is asking, will you consider the time it will take to implement circular economy strategies or their propagation over time? So we know that measures will take time and he gives an example for instance, switching to new building structures will take time. And also designing a product will take time. Will we consider this? Thomas, do you want to?
Hello, yes, can you hear
Yes.
me?
Yes, perfectly.
Yes, it's like you already mentioned. So it's about the time it takes to implement strategies, switching to multifamily, or if you design a recyclable product, then it will take time before that product can actually be recycled. So the benefit happens in the future. It's all not instantaneous, which is often considered, which might have a dire implications on the results of the project. I don't know if this will be considered.
Yeah, so to some degree, some of the models take a part of this inertia into account. So if we take a material flow model or an integrated assessment model, most of those have some description of the infrastructure, and therefore they describe how much buildings there are, and therefore how much new buildings there will be built. And as a result, the circular economy measures that you introduce are bounded by the new infrastructure or by the outflow of materials out of the economy. And so that inertia is included in at least those models that prescribe it in process. There are also other inertia, how fast a product can enter the market, how fast people change behavior, and things like that. There, at least the material flow models and integrated assessment models that I know need to make simply assumptions on how fast they could assume that the technology can be introduced. And so that to some degree are somewhat ad hoc assumptions. The economic models, some of them might not have time dynamics, so that they automatically have to make an additional assumption as well about the implementation rates of how fast things can be implemented. And there potentially the fact that we have these models together in the project could be of help. You could use an integrated assessment model or material flow model to look at how fast it is possible to switch to redesign of cars and see how fast that impacts steel use. And that information then could be handed over to the CGE, which then has the advantage that you can analyze also strategies from different perspectives. I hope this helps a little bit. And then maybe if somebody wants to add from another model perspective to this.
Thank you, Thomas. I think it's also crucial quickly that we are time explicit, right? Unless, for example, in an LCA where things happen instantly, we really track the dynamics and the evolution of the built environment over time, both in economic models, step-by-step, equilibrium iteration, and IMs are time explicit as well. And industrial ecology models here as well, stock flow dynamics. And also our main reporting template, the IMC template, has a time series as its main dimension. So everything will happen when it can happen from the lifetime perspective.
Thank you. So more questions?
Also from the room here.
And also from the room, yes. We have 48 people online. I'm not sure if you have questions to the speakers.
Who is online actually?
Ah, okay.
This is a question from Carol.
Yes. So how were service demands such as floor space per capita or transportation were calculated, and how do you translate service demand into product or material use in the models? If not, I can also answer.
For the modeling part, I mean, how the service, for example, mobility service is translated in a demand for materials. So louder. So there is let's say this concept of consumption by purpose. So households consume mobility, and then you have a consumption matrix that decomposes the expenditure on mobility to specific materials, goods, and services associated. So each service, even mobility, but all other services, have a mapping to specific materials. Now, this is a two-layer or two-stage approach. In the first approach, you assume that you need vehicles, or you need, let's say, buses, or you need, buildings for, depending on the purpose, actually. And then this is linked to specific materials within the model in terms of either production or consumption. So I don't know if I was clear, but this is at least is the method for the models.
Do you want to add, Patricia? Because I think the important thing is also that we have 3 types of model communities in the project. And so each of these model communities might do this in different ways. And so the description that you just got is the way that a CGE or economic model would do this. An IAM model also has different services and typically has looked at relationships in the past between these services and indicators that are projected like GDP. And so to take your example of the floor space per capita, if you plot GDP versus floor space globally, you see a specific relationship that is being used then in the integrated assessment models to also project future floor space area and therefore buildings into the future. Material flow models might even use a different approach or something similar than that. Maybe Stefan, how do you project per capita floor space?
Or where should I ask Thomas instead? I think.
Hello, Peter here. So yeah, in the stock flow models, the floor space is usually an exogenous variable. So the trends over previous decades are analyzed, and then sometimes based on population growth or GDP or other indicators can be projected, and then in scenarios it basically is an exogenous assumption to change the future levels, and that, like with respect to the first question, that should also be done in a way that respects the dynamics of the turnover of the stock. So there are limits to how fast or slow the floor space might change. And then the translation into material use, the second part of this question is quite simpler. It's basically using material intensities per meter squared or per service unit, and these are taken from a lot of literature and made specific to the region and the building type.
So thank you. I don't know if someone has more questions. Yes.
I just want to say there's a little bit more behind the second question, because we do have product archetype models, and they represent products in physical terms and their functioning. For example, we have a building model, Build ME, where we have an architecturally correct representation of the buildings, and then we might change some structures, for example, from steel and cement to concrete and steel to a wood-based structure, or we might look at the reuse of specific elements of the buildings and investigate that. And that then, so there are some of the circular economy measures that are actually taken at the level of the product models. We can also look at LiDAR construction based on investigations in the literature, and this is then sort of the data that is available to the models that make decisions about which measures to implement.
Yeah, maybe to add also quickly to that last question, if I must, may I, Patricia?
Yes.
Because what I see simply is that from an integrated assessment modeling perspective, if we normally calculate emissions, we take activities and we multiply it with emission intensity, and that's relatively straightforward. I think here things are quite a bit more difficult because you have so many different design types for products, but also different parts of the world. And we already saw and that if we are calculating material demand for buildings, that we can find data for building types in Europe or in the US, but it's hardly possible to find these material intensities for building types in Africa. And so this is going to be quite a challenge still in the coming years. And the more we can build up databases on these material intensity per product type in different parts of the world, the better the data will get.
Okay, so we have a new question from Cecile. So how new is the data that we are working from? And she also asked, so it was shown in the beginning that we are not using LCA. It was out of the scope of the project, but did some considerations or thoughts about it? It was considered. So I think we are using LCA.
Well, some of the data comes from LCAs, right? And for example, the archetype models that we build for the products, you can do an LCA of the archetype. It's just the calculation that does not consider time explicitly, doesn't consider the cohorts of buildings. It's just an LCA of one of the buildings that we are considering in our project. And so this is often quite useful. We find that at that time, at that step where we have defined the different alternative archetypes, building with a wood-based construction versus a concrete-based construction, we can compare the impact of that change on the building's embodied materials and energy through a life cycle assessment.
So you also have a question from Gillian about the data for reuse, which is difficult to find. For instance, for building again, what are the data that we are using and what are the assumptions that we are making? For instance, when it's the baseline, what kind of data we are using for the baseline? I don't know if Stefan for the data or Edgar? Martijn?
I can quickly add first on the previous data question. We generate own data. We have a survey, right, in Work Package 4 on consumer behavior on appliances. So I think this must be mentioned. On reuse, the reuse data we used are from case study projects for buildings, mostly by our colleagues in Cambridge who have published this potential for reuse of building steel, of construction steel. We have also same estimates for vehicle components, and we have the circularity of wood use from buildings, where we also have current data. So it's, I would say it's not the latest data. It's also rather uncertain data because depending on what exact building and vehicle you have, different percentages can be reused, but we have a reasonable share that we are on the safe side to saying, hey, this is possible.
Okay, you can also raise your hand and you can speak if you want. And people in the room as well, you can.
I have a question on actually to Leonidas and the CGE colleagues. And this is on the modeling of critical materials in the CGE models. To me, these are two different worlds, right? Some critical minerals, we have maybe the production volumes globally is a bathtub, or maybe it definitely fits in this room, but CGE model has the world economy covered in the 30 sectors. So how do these two extremes in resolution fit together?
So the point here is to identify, because exactly you cannot capture everything, and is to identify the critical materials that are mapped or part of a technology that is very important either for decarbonization or for any other reason. So it could be batteries, it could be, so you need to make this mapping. And once you do that, then at least in GEMI 3, where you have batteries or you may have wind or PV, let's say, panels manufacturing separately. So actually you identify an economic activity, and then you say in order to produce batteries in this country, you need this very small amount of this, and this is essential. It's not a substitution, and then you cannot produce without this. So even if in this, let's say, granularity of in a representation where actually you have sectors, so you have map, you are also able to have like in the electricity, you can have specific technologies or specific products, but depends on the focal point. So if you decide to have one rare earth material that corresponds to a specific technology and you want to trace this, you extend the input out table towards this direction. So this is the way to do it.
So the way of adding these satellites information, the quantity of critical. Okay, I get it. Yeah.
There is no just. Okay, she's saying hoping to get some thoughts on the derivative versus the sequential LCA.
You have an LCA?
Just a
So I guess the modeling that we do can be seen as consequential because the models, the economic models and the integrated assessment models, they have all alternative products available and they choose according to the model's logic, for example, looking at the minimization of the costs or the optimization of the global benefit, they pick those technologies that are best under the modeling criteria.
If it is, Thomas has a question. If it is the desire to model plausible, realistic, consequential scenarios and not unrealistic ones, have you then also considered the consequential variants of echo event and axial base? The answer is no. Edgar is saying no.
Can
They
you
are not.
explain why?
Because the modeling logics that is embodied in those two data sets, first of all, I would venture that they are flawed, and for the other ones is that we have our own modeling logics that are endogenous to the economic and integrated assessment models, and the models have available the data. It's sort of a unit process representation. Where other inputs like materials production and energy production are considered as variables that the models make decisions on, and that is in addition to making decisions on the employment of the technologies that we investigate.
So maybe quickly
Thank
wanted
you.
to follow up on the question that was asked by Stefan on the critical materials, because maybe if you were looking at our presentation so far, you would realize that we didn't speak a lot about critical materials. And the reason is simply that CIRCOMOD has this focus on bulk materials from the perspective of how much can circular economy measures contribute to climate mitigation. And we when we wrote a project, we were really focused on that impact via the energy system. Obviously, more and more people are now interested also in how the supply of critical materials relates to the energy transition. And so I think in follow-up projects, we really have to start looking into that much and more, certainly in a world that is getting increasingly geopolitical.
Okay, no more questions in the chat. I don't know if someone in the room. I have one tricky question. How will we deal with trade? Okay, because we are absolutely quiet about trade. How we'll model that? What kind of assumptions should be considered?
Yeah, so I think for the CGE models, it's not a really real problem. It's endogenous in their model.
Yes, I mean here it is mostly on data. I mean, and rather than on the endogenous representation. So it is the trade that you have on materials embedded in goods, which we have now. I mean, so the trade in equipment and steel, this is quite detailed in in the modeling. In our standard CG modeling, or the default assumption is that all materials are imperfect substitutes. So even if they are the same, I mean, if it is steel, I mean, you can consider that there are different qualities, different, I mean, there are many different reasons for which you can actually have the same material imported from different destinations, from different origins. So the trade representation in CGs is straightforward, at least in its basic form. The difficulty is on structural changes. So once we have established the base year, let's say, trade pattern, whether you are able to significantly change it over time through, because if you have only price differentials or price, let's say, changes, they are not always sufficient to drive structural changes in trade. So I don't know.
So also in integrated assessment models, we have to deal with trade. So most of those already model trade and energy resources, and there we can basically understand some of the dynamics. We see that producers that have cheap energy sources are exporters, and those that don't are energy importers. And so we tend to describe those markets in terms of prices, and then we add some monopoly behavior on top of that. For materials, it's not always as easy. If you would expect a steel producer to have at least cheap energy or have steel resources, you would not expect South Korea to be a major steel producer. And so obviously industrial policies have an important impact here as well. So far in image, I can say that we simply have a trade matrix, and we can assume that that matrix stays the same or not. Yeah, obviously it's interesting to think a bit about what determines future trade and resources.
Okay, so we have a question also from Simon. To what extent do you test the sensitivity of your models on parameters such as inertia, square meters per capita, and also algorithms that model supply and demand interrelations? Some of the modeling team wants to answer.
Thank you, Simon. I think the biggest sensitivity analysis we make is testing different scenario assumptions from no circularity to different circularity degrees, because this is the main variability we have. And then we have different scenarios, baseline and policy, that capture, so to say, the very different worlds we could live in. And these together already give very different pathways. And of course, we know that within these pathways, there is more uncertainties of different parameters and so on. But we already have covered this wide range. So we focus on scenarios and then different CE options. And the other thing is, on some of the input parameters, we work for consistency rather sensitivity. So we want to agree on the best estimate for floor space that we start with, or the best passenger kilometer estimate. So reconciling the difference that Peter has shown before, instead of having a variability there.
Just to add a small bit on that, another way that we, like, if we are interested in sensitivity for the purpose of seeing which variables are more or less important, then in the different scenarios we have, we are just starting the process of defining different targets with different circularity measures, and then we will be able to quantify the relative impact of changing one variable or another.
Thank you, Peter. So, do we have a last question? Oh, yes. Okay, so we have a final question from Gecko. Does CIRCOMOD couple the different kinds of model so that they can complement each other in resolution or scope? If so, it is a static coupling or dynamic? Good question. Such as the sequence of running the models can be adjusted for different research objectives.
Yeah,
This is a very good question. Arjen, do you?
Yeah, exactly. I was going to just say that's a very good question. It's kind of also what we are breaking our head a bit about, but we have both in a way. So some, and I think Peter showed that also. So in some cases, different types of models are coupled, mostly on the kind of energy and materials scope. So really to understand how changes in one system affects the other. And in other cases, it's more static couplings, and that's, I guess, more between the economic models and the physical-based models. Where, for example, the physical-based models can give information about the amount of secondary materials that are available, right? They have a lot more details there, and that would be very relevant from the economic models to know more about, and vice versa. The economic models can say more about rebound effects, for example, on economic growth, right? So that's not a dynamic year-by-year coupling, but it would be kind of running the scenario and then exchanging information.
I think it's answered. Okay, so I think we can close. Thank you very much for the presenters, the people online. I hope you get some overview, good overview of CIRCOMOD project. You can always enter our website and send us emails if you have additional questions. We are always available to answer you. And have a nice day. And thank you also you to be here. Thank you very much.